Okay, so now we're going to be talking about the concept of enzymes, and this goes back, the last concept that we just talked about was the different types of reactions. But let's ask ourselves, if I was to place these two reactants on my desk, would they spontaneously come together, do you think, on their own? Probably not. Or if I was to put this on my desk, would they spontaneously on their own fall apart? There's a likelihood it could happen, but it's very, very small, and it would probably take a very, very long time. So what you have to have is you actually have to have things to help that to happen. And those are my hands. Okay, these facilitate them. If we're thinking about, they're the things that pick them up and physically put them together or physically pull them apart. So if we're going to relate that to what's happening on the chemical level, my hands are enzymes. They help reactions to happen. Okay, and so enzymes, they're just proteins. They're inside your cells, outside your cells, they're all over your body, and they're going to take reactants and make products. They help those reactions happen fast enough that life can actually happen. Okay, so let's look at a few concepts here. So, one thing I want you to look at right here is this graph. And remember, anytime you're looking at a graph, you want to look at the x-axis. Okay, and we see the x-axis right here. And notice the label. It says progress of reaction. Okay, so what that means is as we start on the left side and move to the right, the reaction is happening. So we could actually label this blue box as reactants. We could label this over here as products. And notice we're moving from reactants to products. Now you may see there's a little dip here, there's a red line, and then you also see this dotted black line. Okay, so let's think about this for a minute. What's happening? Well, as we move from reactants to products, this axis right here is energy. And you notice, let's follow the dotted black line first. This is how much energy we have to move from reactants and products. Okay, so what does that mean? Well, here are my reactants. And so without an enzyme, they would have to bounce around so much, so quickly, that they spontaneously come together if they do not have an enzyme. Okay, so if we're going to go back here and label this black line, we would name it the amount of energy needed without an enzyme. Now let's look at this red line here. Okay, this is the amount of energy, and that specific type of energy is called activation energy. You'll see that term up here. It's explained here. Okay, so this is the amount of energy needed if you do have an enzyme. So again, let's look. If my hands are in the picture, they're helping this happen, well, then that means that these things don't have to have that much energy in order to come together. Okay? And so without an enzyme, these things got to have a lot of energy on their own to spontaneously come together. But with an enzyme, they don't have to have much energy because the enzyme grabs them and puts them together. Okay? Now, a couple of other things is that right here, this paragraph, temperature and pH affect enzymes. Okay? For my enzymes, my hands, to work properly, the temperature's got to be right, the pH has got to be right. And so that means that the body has to keep temperature and pH in strict homeostasis. And we'll talk a little bit more about what pH is on the next page in the lesson.